Good day, everyone. So today our lesson is about remainder theorem. So remainder theorem says that when you divide p of x by x minus c, then the remainder is a constant equal to p of c. That is, again, remainder is equal to p of c. There are two ways to find the remainder. One is synthetic division and two is to calculate P of C. First way to find the remainder is by using synthetic division. So when we use synthetic division, we only use the coefficients of the polynomial expression. So take note, this is your P of x divided by your x minus c.
There's so much to it.
So the coefficients are, we have 1, 2, and 5. Then for our divisor, that is equate x minus 1 to 0. Then x is now positive 1. So this is our divisor. First step is to bring down 1 and then 1 times 1, that is 1. Then add 2 plus 1, that is 3. And then 3 times 1, that is 3. And then 5 plus 3, that is 8. Therefore, our remainder is equals to 8. Another way to find the remainder is to calculate P of C. That is, we need to evaluate P of x at C by substituting C for x. So the same given, we have x squared plus 2x plus 5 divided by x minus 1. Now take note, our divisor, that is in format x minus c. So the value of our c is equals to positive 1. So we will substitute c equals to 1 for x. So that is p of x is equals to x squared plus 2x plus 5. So p of x, so our x, again, c is equals to 1 for x. So the value of x now is 1. Substitute all the variables x by 1. So you'll get 1 squared plus 2 times 1 plus 5. That is 1 plus 2 plus 5. So our P of C now, or our remainder now, is 1 plus 2 plus 5, then that is equal to 8. Another example is find the remainder of 3x squared plus 7x minus 20 divided by x plus 4. So first, let us use synthetic division. So again, we only need the coefficients of our dividend, and always remember that your polynomial expression, or p of x, or your dividend, is in standard form. So our coefficients are 3, 7, and negative 20. For our divisor, let us equate x plus 4 equals to 0. So our x now is equals to negative 4. So divisor is negative 4. First, bring down 3. Then 3 times negative 4 is negative 12. 7 plus negative 12 is negative 5. Unlike sign, so you need to subtract. 12 minus 7 is 5. And copy the sign of the bigger number. The next, negative 5 times negative 4, that is positive 20. Negative 20 plus 20, then that is 0. So our remainder is equals to 0. Now let us calculate P of C by substituting C for X. So, our divisor X plus 4, that is in the form of X minus C. So, our C, since this is a negative sign, our C is negative 4. Okay? That is just equal to X minus negative 4. Okay. Now, P of X equals to 3x squared plus 7x minus 20. So our x is negative 4. All the variable x must be substituted by negative 4. Plus 7 times negative 4 minus 20. Okay, next. Follow PEMDAS. So negative 4 squared, that is positive 16. So that is 3 times 16. And then 7 times negative 4 is negative 28. And then negative 20. Next, 3 times 16, that is 48 minus 28 minus 20. So 48 minus 28, then that is 20 minus 20. So our remainder, or P of C, take note, P of C and remainder is just the same, okay? So that is now equal to 0. So same answer with this. Next is factor theorem. So factor theorem, the polynomial P of x has x minus c as a factor if and only if P of c is equals to 0. So if your x minus c, or your divisor, is a factor of P of x, then your remainder is equals to 0. Now, letter B, if your remainder is equals to 0, then x minus c, or your divisor, is a factor of P of x. So let us have an example. Show that x minus 1 is a factor of 4x cubed minus 4x squared plus 4x minus 4. Now, in the lecture, they use the second way to find the remainder, which is by evaluating or substituting the value of c. Now, let us try to use synthetic division to find the remainder. So since it's already in the polynomial expression is already in standard form, so we will now write that is 4, negative 4, 4, negative 4. For our divisor, equate that to 0. Then our x is equals to positive 1. So divisor is 1. Bring down 4. Multiply 4 times 1, that is 4. Negative 4 plus 4, then that is 0. 0 times 1 is 0. 4 plus 0 is 4. 4 times 1 is 4. Negative 4 plus 4, then again, that is 0. So therefore, we conclude that x minus 1 is a factor of 4x cubed minus 4x squared plus 4x minus 4, since our remainder, or P of C, is equals to 0. Next example, let us show that x plus 2 is a factor of 4x cubed minus 4x squared plus 4x minus 4. First, let us use synthetic division to find out the remainder. And then later I will show you the second way, which is to calculate or evaluate the polynomial expression. So for synthetic division, again, write the coefficients. So we have 4, negative 4, 4, and negative 4. For our divisor, we will equate x plus 2 equals to 0. So the value of x is negative 2. Okay. First, bring down 4. 4 times negative 2 is negative 8. Negative 4 plus negative 8 is negative 12. Negative 12 times negative 2 is positive 24. 4 plus 24 is 28. 28 times negative 2, that is negative 56. Okay, then negative 4 plus 56, then that is negative 60. So our remainder is equals to negative 60. Therefore, x plus 2 is not a factor of 4x cubed minus 4x squared plus 4x minus 4. That is by synthetic division. So what if we will substitute the value of c? Now again, our divisor is x plus 2. So the format of our divisor is x minus c. Therefore, c is equals to negative 2. Our p of x, that is 4x cubed minus 4x squared plus 4x minus 4. Substitute x. So c equals negative 2. So therefore your x is also equals to negative 2. Substitute all the variables x by negative 2. So this is a negative 2 raised to 3 minus 4 times negative 2 raised to 2 plus 4 times negative 2 minus 4. So negative 2 raised to 3, that is negative 8. So 4 times negative 8 minus 4 times negative 2 raised to 2, that is positive 4. Then 4 times negative 2 is negative 8 minus 4. 4 times negative 8 is negative 32. 4 times 4 is negative minus 16 minus 8 minus 4. So 32, since all of them are negative, so 32 plus 16, that is 48 plus 8, that is 56 plus 4, then that is negative 60. So again, our remainder, or P of C, is equals to negative 60. Therefore, x plus 2 is not a factor of the polynomial expression.